That is Peter. And on this sunny day, he, like many others, has an appetite for a big ice cream. There he is already. Which ingredients are needed to produce ice cream? And how is it even made? Why compressed air? Peter asks himself. He hasn't thought about it yet.
Compressed air is used, cause the air pockets increase the volume of the ice cream, and make it creamier.
This is quite a great invention. But isn't normal air filthy, and contaminates the ice cream with unwanted, or even hazardous substances?
No need to worry, dear Peter. Compressed air is needed, in almost every production process. Compressed air comes into indirect, or direct contact, with the food. Anyway, a high degree of care is required for this process. In indirect contact, for example, the cleaned yogurt jar is dried with compressed air. Direct contact occurs when the product is filled with compressed air. Finally, the closure of the jar is transported with compressed air, and closed. Contamination by microorganisms, oils, or particles can contaminate the end product in both indirect and direct contact, and cause an enormous loss of quality. There are different and effective approaches to ensure food safety. For example, the HACCP, a management system for hazard analysis and definition of critical control points, as well as additional processes to measure, control and minimize risks, like the Operational Preventive Program, OPRP. Manufacturers are obliged to produce a safe product. The producers themselves are responsible for determining and monitoring their compressed air quality. This is expressly stated in the standard EN ISO 22000. The requirements for a management system for food safety are defined here. The standard applies to all organizations in the food chain, regardless of their size and complexity. The requirements for the safe manufacturing process do not only apply to our own production, but also to that of each supplier. For the entire production process, including transport, food safety requirements must be met. The example with the truck shows that even a clean product can still be contaminated in the last few meters. Via the truck's compressor, unfiltered ambient air would be sucked in and used for the unloading process. A suitable compressed air treatment system must always be used for safe loading and unloading. The standard ISO 8573, for example, stands for the quality requirements for compressed air, and specifies the maximum content of solid particles, air humidity, and residual oil, or oil vapor, that may be contained in the respective classes. The quality classes for compressed air are indicated by 3 digits. The first digit stands for the particle size, the second for the residual humidity, and the third digit for the oil, or oil vapor content of the compressed air. Depending on the required quality class, an appropriate treatment of the compressed air is necessary. This applies to the food industry. There may be no entries into the food from sources of danger by compressed air. In case of direct contact between product and compressed air, the quality class 221 is recommended. In the case of an indirect contact, the recommendation for the compressed air quality is class 242. As a reminder, please refer to the table again. With a compressed air quality of 221, there may be less than 100 particles, with the size of 1 to 5 micrometers, in 1 cubic meter of compressed air. The residual oil content, in this cubic meter, is limited to a maximum of 0.01 milligrams. If one now considers the middle figure for the residual moisture, a pressure dew point of -40 degrees Celsius is required. Special dryers, such as adsorption dryers, must be used for this very dry compressed air. The location of the compressor has a great impact on the quality of the compressed air. The more polluted ambient air can be sucked in, the higher is the risk of contamination, as well as the effort required for the safe treatment of the compressed air. It should also be noted that the ambient conditions, such as day and night, can change considerably. The air volume sucked in, and thus all substances contained, are compressed to a smaller volume by the compressor. For example, with a compression of 10 cubic meters of ambient air, with a system pressure of 7 bar, after compression all components of the sucked-in air are contained in approximately 1.4 cubic meters of compressed air. It must therefore be expected that after the compressor, a mixture of particles, humidity, oil vapor, and germs is contained in the compressed air. However, these substances can be removed, or their quantity reduced to a harmless minimum value, by optimal compressed air treatment. It becomes problematic if the proper function of the compressed air preparation is restricted by a defect or improper maintenance. Here there is a very high risk of contamination of the product. The influencing variables are the time of malfunction, temperature, pressure, and humidity. Even minor defects in the compressed air treatment, for example due to malfunctions or improper maintenance, can have a considerable impact on product quality. In order to exclude risks from the outset, a perfect compressed air and adherence to the required quality class are required. Contaminated foods could pose a health risk for the consumer. In addition, sellers and manufacturers may incur considerable costs and legal consequences. Depending on the contamination, and the quick reaction of the industry to detect and avoid it, the loss of image and negative consequences for a large part of the food industry can be expected. To sum up, the quality of compressed air has a direct impact on the safety of the end product. Therefore, it is essential for a safe process to measure, check, and record the compressed air quality completely. In addition to the applicable standards and guidelines, this evaluation is based on the manufacturer's in-house specifications. Complete documentation guarantees optimum monitoring of the required compressed air quality, even during internal and external audits. The complex processes and connections require a technical understanding of the production medium, compressed air. Picode Technologies has its own e-learning module on this subject. The responsibility lies with you.